button, and then now.
Oh, good morning.
Wonderful.
Welcome. This is Science Mesh. So, okay, welcome. This is the Science Mesh workshop, also known as CS3 Mesh for EOSC, which was the project name that created the Science Mesh. My name is Renato from Switch, and I'm happy to present you the almost endings together with my colleagues Guido from SUNET and Maciej from PSNC. We're kind of proxies for all our other colleagues involved of the project, and we're happy to do this at TNC. So, Science Mesh. Why do we have this slide? This is Science Mesh.
It's the logo.
Yeah.
We have a logo.
Yay.
We have a logo, and we prefer this name over the impronounceable CS3.
Okay, yeah. This is a short agenda how we imagine this morning is going to happen. It's kind of a suggestion, and we try to stick to it, but if we don't be mad at us.
It's very much a workshop, so interrupt us at any point, questions,
Yep.
etc. This is not a presentation purely.
It's a bit it's not the best setting for a workshop, so it looks like a frontal thing, but shouldn't be. Yes, Science Mesh. I still start with the weird acronym. It all started, I think, at this is in the wrong order. In the 3.5 years ago, when CERN mainly initiated the project to get funds to build this. It should be a decentralized mesh of enterprise file sharing sync and share nodes. There has this community, the CS3 community, where C stands for cloud, S for, the 3S for sharing, help me out, storage and synchronization. Right, so we actually are meeting since, I don't know, 2015? 13 every year or every other year, depending on how the pandemic status is. Out of this, first started the open mesh, open cloud mesh, which was able to share file within own cloud instances that are not in the same, well, apparently not in the same instance. And it's based on open standards, developed as open source software. It should be a federated space in the European research community. Yeah. I don't know why this is upside down, actually, but
some things are upside down.
But this was the starting point in Rome, 2019, when we finalized the proposal.
Turn them upside down, you shake them, whatever falls out.
So this is a compatibility issue.
Yeah.
PowerPoint and
Well,
I didn't, yeah. No, it was in Rome, actually. So, there are 3 dimensions to this project, Mesh. I'm presenting the first one. We're 3 people, so figure out how it will go. It's a trust-based foundation. We actually took a lot of concepts that were already there, for example, in security or in identity, and we basically just copied them. So it's the goal is a mesh of trusted organization where you are able to share data with your colleagues that are not in your organization. most initial thing is this OCM, the Open Cloud Mesh, which was, I think, discussed 2015 at TNC in Porto the first time. And Terena/Géant has initiated that by that time. And OwnCloud, Nextcloud, and cFile has implemented it. I'm not sure about cFile much. Are you correct? OCM is okay. Then the CS3 mesh for EOS project that we started in Rome has taken up on this and has taken it as a basis for the CS3 API development, which is now come off that project. It's one-to-one communication about between EFSS systems, and we trust the other person because you should actually know the person you're sharing with, and so yeah. I'm going to show you the very basic workflow where Maciej later is showing you the actual video how it works. So we have two users. We have Pedro from CERN, we have Ron from SURF, and they want to access their data. So Pedro creates an invite link and sends it to Ron. And Ron clicks on the link, goes to the mesh directory, selects his EFFS, I can't say it, his surf drive where he is accessing his data, authenticates there at surf drive, and then surf drive says yes, this is Ron, and sends this back to CERNbox, which is another OwnCloud installation. And the fun bit is nobody needs to care whether it is OwnCloud, it's a new OSIS, or is it Nextcloud, or in the end cFile maybe. So they don't need to know that. It's just a seamless integration of sharing, and then Ron can access Pedro's data. Through OCM, the underlying technology. Right. This is the invitation, how you create a link, and this is how the mesh website looks, where you have to choose your system that knows you and can tell that you are you and you're the right person. And I think that's it for me.
You want me to do this one? The first one. The first one.
All right. Because that's to make the point. That's to make the point that the interoperability layer that we build, given that it's in place anyway, you can use it in more ways than one. You don't just have to have it talk between the different sync and share systems. If you have an API layer in place anyway, you don't have to do east-west. You can also go north. And the idea there is that if you have an API talking north, you can have universal deployment of applications. So the applications, any application that you build, any new application that you build, you don't have to link straight into the vendor APIs. You can also link them through the interoperability layer that we've built. So if you, at an NREN or at a science facility, decide to build a new science workflow, if you link it into these APIs, we can guarantee that any site that you deploy it onto in this mesh will be able to give you an underlying file, upload, transfer, curation, etc. layer. And to prove that point, one of the work packages inside of the CS3 Mesh for EOS project, work package 4, led by Maciej, by the way, piloted 4 of these applications to prove that point. 4 applications which we handpicked to be representative of science flows, and also to show that all vital data operations can be abstracted through this API. So we've got one where we prove that you can do data munging on top of the APIs, simply by launching Jupyter Notebooks and doing a whole lot of magic. We have a video on that. That proves that you can have decently low I/O on the files that we're presenting and do file locking, etc., over the API. The second one is open data systems, where we actually do have a fourth participant for today. Good to see you, Richard. Where the point is that we are proving that we can pick particular sets of files, add metadata, and link them to third-party cloud systems, which is useful in the whole EOS context. This in the context of deposition of data. A fourth one, collaborative documents. So the ability to, of course, there's a bit of a Me3 going on here. If you have a Dropbox-like system, a lot of users will go, well, you know, Google allows me to also edit those documents. Well, so we kind of have to show that we are feature compliant. There are systems that can do that, notably OnlyOffice, Collabora. There's a few other open source versions as well. So we're proving here that we can do that. Again, the low I/O. Again, the ability to have multiple users collaborate on via disparate systems on the same file. And a fourth one, the ability to move entire data sets between the different nodes. So to have users initiate one of these transfers, showing that we basically have a programmable API, so that you can schedule something in the underlying system and have the remote system abide by the same API rules. We thought that those four were useful in their own right. I actually hope that resonates with you. I hope that some of these make you think of use cases that you have back home, and to prove that we had an API that was fit for purpose. I can't really think of any other VRE type operation on your files that doesn't map on any of these. If you have it, let us know, and we should at least be able to have a think of how that fits on the APIs. That gets us to the data science environments number one. I think you've got the preso on that one.
Yeah,
Wonderful.
so.
Okay, so I'll try first to overview in order to avoid switching the slides from slides to videos. I'd like to first introduce you a bit deeper into these application areas. And as Guido said, we treat this both as usual use cases for which we have user communities interested, and they were already in the project, actually part of the initial consortium. But we also piloted and replanted the solutions in these areas, within application areas, to some other institutions, so that, I mean, we, in a way, also prove that the architecture we worked out is actually suitable for reuse of the results of the project. So the first idea is a very cool area, is actually data science environments, what we worked on. And here on the right side, we've got the list of technologies which we used, with Jupyter Lab being the obvious, let's say, de facto standard or the default tool for working in this area. So the idea was that we would like to ensure that people can collaborate using data sets. And because typically data science is a kind of data-intensive work, the idea was that if we have, we would like to make people able to use in their data science workflows the data which they have in their EFSS systems. And this is actually also going to be, I mean, it's becoming more and more popular approach to actually performing data science. So we were working on enabling Jupyter Lab to first of all store the notebook data in the EFSS systems, so that your code of your work you run is actually stored there, and it can be shared with all interesting and important semantics. In the demo video, we'll show you that we can not only simply store the data and share them, but also some kind of more advanced mechanics are there, such as locking, such as detecting differences between the versions, merging the versions which were created through perhaps improper handling of file versions between users, and so on. So that was actually, I would say this is a fully fledged integration of the application with the EFSS backends. So this is let's say, one dimension of the integration. The other is that we target the situation where you could have different backends and you can also share across them. I mean, by different backends, we mean different EFSS systems, which you have depicted here with their logos, for instance, OnCloud and Nextcloud. Yeah, and all this is targeted to facilitate the data science and also avoid, I mean, as Gita said, people can perhaps live with Dropbox and other services. What we try to do is at least approach the similar level of integration of the services, so that if people deposit the data to private clouds, let's say, to the on-premise storage at data centers or in RIANs, they are also, in our vision, they're also given the tools to work on this data, not just store them. And we want them we want to avoid situation when they only perceive our systems as to be the storage systems or data deposit systems. We want to give them this, let's say, portfolio of applications which support their science on the data-centric science. So in the demonstration, we will show that we show the example of two scientists who share the notebook, and also kind of like they perform several rounds of the collaboration. They do changes, and these changes are visible, and there is a conflict situation. The locking is needed, and so on. So I will come to that after the introduction. The other area is so-called open data systems area. In that case, we are trying to address the use cases where people normally store their data in our EFSS systems because they give them the easy way and easy and convenient way of collaborating on data. The let's say ultimate goal is to again integrate user workflows in our systems and integrate them in such a way that the users can perform all the necessary steps which are on the way from creating the data and planning the, let's say, their publication and their curation and preparation for deposit, up to the point where they can deposit the data easily without, for instance, downloading them to their machines from EFSS and then pushing them into repository. So we enabled kind of shortcut so that the user who has already data in EFSS and works on them, for instance, by adding some metadata in a collaborative mode or improving the quality of the data set themselves in a collaborative mode, which is enabled by sync and shares and their integrations with office style applications and so on. As soon as the data are ready, users can use this facility for moving the data directly from EFSS to the repository. And for that purpose, we piloted a system based on the service developed and run in University of Münster in Germany, Skibo. Skibo was the EFSS systems of choice. And we enabled and tested also ability to push the data to well-known data repositories, including Zenode and also OSF, which I will show in the demonstrations. So that's the important second use case, and we also perceive this as kind of important in scientific workflows because people often first use the easy to use tool, which is the sync and share system with all the integrations of the collaboration applications, and then when they're ready, they actually need a tool for sometimes massive data uploads to the repositories. So it's not only a shortcut, but it's also this solution also enables people to do to perform this transfer and these deposits in a systematic, managed and kind of automated, even automated way. So in the demonstration, we will show the creation of the data set, enrichment of this data set with metadata, and depositing this data set to the repository and then searching in the repository so that we can see that the data were actually deposited. The collaborative documents area is, I think, one of the best understood. I mean, it's kind of usual business which we do. So the idea within the project was to ensure that we can use the popular documents editing platforms across the federation, which means not only that we can share the files across federation between different instances of the sync and share systems, but we can also, in certain cases, we can even run the application, the editing application, which is available only on one site, versus the data we have on for instance, our site. So we worked on integrating Collabora and OnlyOffice. These are the usual, let's say, usual suspects in this area. And also we worked on integrating CodeEMD, and this level of for CodeEMD, the level of integration is highest. And then in that case, actually, it is possible to run for instance, in our case, the CodeEMD running in a CERN box, versus the data you might have in your local synchronization environment. What is worth to mention is that in that case we were able to reuse and actually we tried to reuse the existing standards as far as possible. In the case of Office application, there is a kind of a de facto standard developed by Microsoft, which is called WOPI, and this protocol is actually used by Microsoft applications to interface with sync and share systems, also other cloud applications. And we were able to great extent to reuse this protocol to improve and tighten the integration between sync and share systems and Office-like applications. Maybe it's worth to mention that we also tried to integrate systems like Overleaf to enable collaborative editing of the, let's say, scientific style of documents. But yeah, we have some issues with this. I mean, this is still on an open topic. Okay, so we will not show the demonstration for that one, but we wanted to let you know that interesting contribution from the project is actually this CodeEMD integration, which I mentioned before. And actually, as soon as you decide to join the federation, you can actually use this feature. So the last but not least is the data transfer use case. An area, I mean, it is important in the times where research and education gets data-centric. So with the large volumes of data people handle, we came to the idea that we should enable automated and managed data transfers between sync and share systems themselves, like for instance from sync and share system at PCNC to sync and share system at SERV. But also we are aware, and we were in the dialogue with the user communities about the need for enabling them to easily and, let's say, in a systematic way, downloading and uploading data from the external infrastructures. For instance, we have this use case on the table in the project. There are data related to Earth science and for instance, satellite images of Earth, which are then processed, and people do both ad hoc editing and management of this data, but they also run computations on top of them. But this data reside in external projects, and the idea behind this use case was, and this also the integration work we did in the project, was not only to technically enable the data transfer, but it was also about dealing with actually accessing this external data set in a systematic way, so that from one hand, if they are massive, this transfer are performed in a proper pace, and they are like performed by external tools which enable restarts, which enable multi-threading and so on. On the other hand, we wanted to deal with things like authorization authentication versus the external sources, so that users using the tools mentioned here, people can actually get access to these data sets. So for this purpose, we used in the first approach, we use rclone, which is a well-known tool. You might know it more as an tool for pushing data from one place to the other. It can also run in some kind of non-interactive mode in the background and implement massive data movement among different sources, speaking different protocols such as S3, SFTP, NFS, or things like that. And in addition, in a second round of the project, we integrated, let's say, more advanced systems such as FTS, file transfer service, well known from for those of you who ever dealt with WACG projects or things like this, and Russia, which is also a very advanced tool for managing and let's say controlling and ensuring the actual execution of data transfers. And this is within this work we again try to make it make this workflow well integrated into sync and shares. So the current status is that we have a code and we have quality tests conducted for CLI-based interface to this mechanics, data transfer mechanics, and we are actually now working on enabling the user interface, graphical user interfaces to these features, and including them into clients and web interfaces of OnCloud and Nextcloud. So that is more or less where we are. An interesting use case which actually applies to, it's also part of the daily business of partners of the project. So both SURF and PSNC participate in the LOFR project, while LOFR has their own kind of flow for the data transfers. From one hand, they collect the data from the distributed instruments, then they centrally correlate the data and push them to long-term archives. So this is actually done already, and it's solved by different tools. We see the growing interest in interactive collaboration based on the data, so that again, coming back to one of these cases I mentioned before, people want, in an early stage of the research, people actually want to deal with the data in the EFSS, so that because it's really easily accessible, you can use like usual Dropbox-like interface to the data itself. But in case of large database projects like that, you have to somehow help them in transferring the data in and out, so that they can actually, so they don't have to manually deal with this large data transfers. So we're discussing and testing together with LOFR people. We are discussing and testing the usage of EFSS as a kind of a tool for the early stage of the research on this in this data-centric domain. Okay, so then I will try to show you two demonstrations, unless there are now any questions to what has been presented on applications.
What are the policies towards S3 buckets? One S3 bucket per client, or client controls this, or is it transparent? He doesn't see it?
Actually, we're not that much dealing with the backends here. We mostly focus on the EFSS applications, which might use S3 as backend storage. But while working on the science mesh mechanics for data exchange, we are actually developing a protocol which is called set of protocols and APIs, which are called CS3 APIs, which are kind of high-level APIs which enable you to interact with the EFS systems. So for instance, mapping this to concrete solutions, if you run OnCloud or Nextcloud, which uses S3 as a backend, we rarely speak to the S3 backend itself. Actually, we don't assume speaking to S3 backend directly. We speak to the OnCloud or Nextcloud server, which then stores the data in the S3 backends.
And how the client controls which node has which data, because some clients are not allowed to store in different countries, for example. How is this controlled?
Actually, as it has been to some extent shown earlier, the science mesh is actually a combination of technical and, let's say, non-technical things. And the technical things enable you to establish trust between the parties. And this is actually the clue of the mesh, that you first, for instance, the administrator of your sync and share system at PSNC and administrator of my sync and share system has to somehow get engaged into a kind of trust relationship. So science mesh mechanics and also policies kind of regulate how you actually establish the relationship. And then if this relationship is established, then you can see each other's shares. But first, anyway, before it happens, you as an end user have to accept the shares from the other user, And this workflow has been shown by Renato, and we also will show this in the demonstration, how this works in practice. But it's not that if you join Federation, you suddenly see all others people's data. It's not the case. It's also not the purpose.
This, but if I create, for example, a folder or some data, to what extent I have control over where it is stored, in which node or in which S3 bucket or.
So by default, it is stored in your home's institution, sync and share, and actually sharing is just actually the metadata level operation. It's not that you physically transfer the data to the other side. It's that you enable kind of visibility of your data to the other user, and then as long as you don't explicitly force the files to be transferred between sites, for instance, using these data transfer tools, they stay where they are. And the idea is also, and it has like, this assumption results from many factors. One of this is that there is exactly this problem you mentioned, that you want to be in control of your data while doing collaboration. And in many cases, and we also see some kind of resistance of users whenever you propose them to use, let's say, cloud solutions, because they want to keep control on where their data are. So the default approach while building the mesh and also operating is that your data stay in your place, in your let's say, mother institution place. You can even, with this example of CodeGMD, it can be even that, and this is, let's say, the maximum version of the federation we would like to achieve in future. We achieved this to some extent already, but only for some applications. In the ideal case, you would, for instance, be able to run the CodeGMD editor at CERN on your file, which would technically mean that, of course, this editor gets feeded with your file, which then goes to the remote location. But as you notice, this is not only a technical problem to do it properly. So we can say that we rather, until now, we rather piloted such a functionality than decided how this will in practice work in terms of the ownership of the file. I mean, ownership is always on you, but then when the data start to like crawl around the network, we have these issues which you mentioned.
Another question, is it within the system a functionality to automate a transfer, for example, from a hard drive repository to tape repository automatically after, let's say, after 2 months of
this is actually data
not using a file, it's automatically transferred to some.
Actually, this is rather, what you're talking about is rather the specifics and the mechanics which are typically implemented on your EFS system side. So for instance, if you use Nextcloud at PSNC, we might have this feature that in the backend the data are moved from the online storage to the offline storage, but in practice we would rather not run the AFSS systems on top of the offline data, because whenever you try, it would then result in a situation that you might click the file and get some undefined latency until you get it. So we rather speak about online data here. And there was actually an idea, but this is a possible future extension of this workflow, that if you are doing, assuming that the user makes his data management in a conscious way, it might be that an evolution of the open data workflow would be that you're not only able to push your data to the repositories, because this is the place in the workflow we consider it is the user who decides that his data are ready for deposit. So there is some awareness on the data management on the user side. We might imagine that you have an integrated long-term archive here instead of this, in addition to the repositories we have. You add some metadata to your archive, and with a similar workflow, you push the data to some kind of S3-backed long-term tape-based storage, but we are not yet there. This is possible, and this could be somehow combined into the work.
So the client is supposed to build his own, I don't know, command line tool and move the data on his own and using his own scheme or
I would say the default interface, what we try to do is that the interface of the user doesn't change. I mean, so coming back to what is the federation, is that the combination of nodes which people normally use as usual, plus some extra features they see, for instance, in your installation of OnCloud, you might see your files, shared files, and we will enable to see yet another type of share, which is the external share, which is not in your local institution, but it's a share over federation, but still for you. The way you access the file doesn't change. This is the EFS system which you use, which is responsible for speaking to the other system so that you get your sharing implemented. But your interface should never share. If we make it changed, then that would be disaster, because I think people will stop use the EFSS because they want to have, I mean, the reason why they use EFSS is very often the easiness of use, because they like mimic the Dropbox-like applications, and they don't have to think what kind of interface they use. They just use the web or the built-in client. And our idea is that we don't modify the built-in client in terms of actual data flow. There are, of course, some extra features we would like to add. For instance, this discovery of the other users with whom you would like to share things. These are the extra things which we kind of inject into clients, but still we want this interface to be as similar to the original one as possible.
Yeah, Ivo Janmaat from Surf. I really like the sync and share part, so also the moving to Zenodo. But for the data management part, we want to use that Surf more iRODS-like system. So if we move the data to archive, we use iRODS, moving stuff to move it there. And then the research group can be managing their own archiving policies, etc.
So if your question is then where we would put this workflow, is this your question?
No, I was also answering the question before that you don't want probably to have the whole data management system into this part, but you want to combine it with other technologies that are out there.
Exactly.
That you can.
To some extent, these are external things.
Yeah, indeed.
We want users to use this. I mean, it is actually that users mostly use EFSS as an easy-to-use interface with low entrance barrier. Yeah. They don't have to learn like SSA, SFTP or grid FTP, grid proxy, init stuff, stuff. And. Okay. Yeah. Okay.
So that would be our
So we could.
Can I make one remark?
Yeah.
The whole point is to deliver sane defaults. The point is not to overbuild what people have in place. The point is that if a user does not know what they're doing, we're trying to give them sane defaults. If you, at a particular node, Surf for instance, have policies and technology in place with enough training that users know, hey, wait a minute, I got a better solution here at the local node. Of course, the point isn't to overbuild that. Sane defaults and easy-to-use access for like the 90% of users who will not drop down to a command line. Because if we don't give that, then we lose those users, and that's worse than giving them a mediocre solution. Not that I'm calling our stuff mediocre, but that's the whole point.
So like looking at the use cases sorry.
It's a workshop after all.
But I just wanted to add to this answer that looking at the use cases which we tried to present, you could include this well-managed long-term data storage, or let's say complicated mechanics on data management. You could see them as a point to which you deposit your data as to repository. For instance, what some repositories do is not only the publication of the data, but you can also have some kind of data management there. So if we wanted to make a mechanics which lets you easily move data from sync and share to this kind of systems. And another example, and let's say possibility, is to use the data transfer mechanics, which will then even make your data flow quite quick and let's say reliable to systems like iRODS-based stuff speaking, I don't know, grid FTP on the front end of WebDev or some other protocol. And with these tools we integrated into the federation, you could actually interface the system and push data there or from them. Yeah.
So I'd like to comment also on this issue. Raman Ganguly, University of Vienna. So I'm from the data management side, and I see this tool, the set of tools what you're presenting quite good, because I think in the data management you will see new new kind of interface involving, because you don't know what's happening with the funders and the data management plan, so maybe you have also to match them, what you have put in the data management plan and then what your actual data. Or some other case, in any way you have to add metadata or you have to control the metadata. So these are the things which will come anyway in some kind of an interface. And these interfaces will then take care of what's happening. But the underlying mechanics or the underlying tools what you have, I think with an API, everything could be managed over an API. Or integrated with other tools, so that this would be a good way to develop or to develop actually a good ecosystem for data management, data sharing, and you have the whole workflow.
Okay, I think there are different ways we could answer this comment or add on top of this comment. I think one of the basic things which we assume is that we will not change the world around, and we don't want to go to the endless discussions on how we would manage the data, because from domain to domain this might be completely different. You might use different approaches, you might understand data life cycle differently. You might have different data sources and the data targets. For instance, that one community or use case could deal with the, let's say, real-time data sources like this loafer case, and then store them for long term, and then EFSS would be just one of the intermediate phases where you store your data and work with them. Same as this publication flow here, that you've got some, for instance, digitization instrument, then you work out, like you curate your data and then you push them somewhere else. So actually, EFSS in that case is some kind of even a temporary space where you actually place your data. And this is, in a sense, our default use case, because people, of course, they use Dropbox-like stuff also to keep their data for years. But we perceive this as in like the broad spectrum of data services. We assume that EFSS is this sometimes default data place, a place where people store their data for some time, and then they do something with this, and including complicated data management, let's say, processes they can implement, but they will for sure differ before communities. What we wanted to offer the community is the, let's say, solution which addresses, let's say, 80% of default actions people do with their data. And that's why we also selected these use cases, so that they kind of, in our opinion, represent the, let's say, kind of default actions which people normally perform with their data while doing research and collaboration.
Is that an adequate answer? Is that an adequate answer? I think we had, you had a question.
So I've got a couple of questions, but let's start with the easy one, which is, do you...
Ready scared, already scared.
Well,
maybe you take over.
So do you require any...
All right.
So do you require to use the API, or, I mean, do you require applications to be integrated with this, or can a standard program that acts as a file just access data through this?
No, we're making it available as a utility. The mesh meshes itself, so the different nodes inside the mesh talk to each other over an interoperability layer, which it's a drop-in plugin, which has actually already been integrated into the next generation of OwnCloud. They've basically just decided to roll that into the code base. It's a little plugin for Nextcloud, and CFile is a plugin as well, right? Yep. And when we realized that we had a plugin there with APIs anyway, we thought, let's also generate an abstraction layer up to applications. So if you want to write your application so that it uses those APIs to talk to generic EFSS systems, we give you the guarantee that you write it once and you can deploy it everywhere. Doesn't mean you have to. If you want to, there's two other ways to go about this. One is decide that you only want to drop it at your local node, in which case use whatever APIs you have, special sauce, or decide that you want to write it 3 times. That's cool too. If you want to make sure that it deploys on Nextcloud, OwnCloud, and CFile, you'll have to write the APIs 3 times, but those vendors make their vendor-specific APIs available too. We're just trying to make your life a little easier, but there is no obligation. And to prove
You can run your default application.
of course, yeah.
You can run your default application on the local node with the local protocol, and the fact that we support federation doesn't stop you to run the normal application on top of it. It might use the fact that there is a federation or not. To use it, you have to go CS3 APIs. If not, you can still run it. So it's not the fact that you're in federation is not blocking you from running all the applications you might have locally. If that was your part of your question.
He seems half satisfied.
Yeah, I think that's a. I mean, perhaps I'm just not familiar with OwnCloud and Nextcloud, but you know, the users I'm familiar with are very familiar with are HPC users and are familiar with the command line, and you know, a POSIX
Not the target users. Happy to serve them, but not the target users. Yeah.
Okay.
Well, the entire thing started from opportunism. So you recognize, this is why the CS3 community started. You recognize that, hey, it looks like we're not the only, let's say I'm talking for Sunet here. It looks like we're not the only NREN that has started a Dropbox-like system because that's the only way to retain a particular generation of users. Looks like everybody else is doing the same thing too. Wouldn't it be nice if those relatively unwashed users could access all of that other data without having to step through all kinds of flaming hoops? Turned out, I was still working for the Australians at that point in time. So actual true story. We realized that the protocols, some of the base level protocols were in place. Much like the invention of Eduroam, most of the protocols were in place. You could link the whole thing together, it just wasn't being done. So we thought, what would happen if we did in fact link everything together so that an individual user could simply reconfigure their data space by asking their remote collaborators who happen to have quota at different sync and share systems at different NRENs, say in Poland. So suppose a Swedish researcher knows that an interesting data set lives with a collaborator in Poland. Suppose that Polish collaborator is also the type of user who, well, not quite HPC. So there's some interesting data on his system, there's some interesting data on my system. This user decides, hey, I can ask that person to make that data available, reconfigure it, and sort of mount it locally. That's the whole point, reconfigure the whole place. So that's power tools that your type of HPC users could do from the command line. It's basically a graphic interface from mount.
And maybe to add to that, the easiest way you could do if there would be no federation would be just to copy data from one system to the other. Yeah. But with the data volumes we have now, we try to avoid it. And as you have seen, this sharing stuff is mostly about establishing the links. It's not that much about moving data around.
Yeah, and also you're absolutely ruining your namespace that way. But yeah, so does that answer question one now?
I have a much better understanding. That's really, really useful, actually.
Lovely, good.
So the other
question two, we're ready for this.
Was it already?
So
Renato, you ready?
1B.
If it gets too difficult.
So there's, I mean, in the UK, JISC doesn't provide data storage, no. But we do provide federation services. So is there anything? So there's two parts to the question. One is there anything else JISC needs to provide other than the IDP, the federation that it already provides, and what would somebody else? If a university wished to provide this sort of service,
first of all, we'll come to that. Second, we don't expect this to be a federation of pure peers. There'll be a tiering system. In fact, some of the partners inside of the CS3 mesh system are universities. So we don't expect everybody to be at the same level. Well, everybody's a peer, of course. What I meant is the same level of aggregation. There's NRENs in here, PSNC, Sunet. There's large research outfits, CERN, LOFAR. We also expect to have small universities. We even expect some countries to simply let the universities enter the mesh, and other countries to want the NREN to be the first level aggregator. It's all possible. That's basically policy. The protocol, same as for Eduroam, right? Do you have local tiering, or do you simply allow everybody into the local node? We'll have to figure this out and go as we. So it depends on what role JISC wants to play, but happy to talk.
Let's talk offline.
Good.
Comments on that? Because maybe they should
Talk to the mic.
Hi, yeah, Richard Freitag from Sweden, and we have built this federated type of mesh for Sweden, where every university has their own Nextcloud node, basically, and we use seamless access and a Satosa for the discovery service for the delegation of the users to the different nodes. So the local users, I mean, they can use SAML login, and then also you always have this federated cloud ID, which you then can use to share. And you can implement your own policies about the sharing. As it was mentioned before, if you receive a share, you have to actively accept the share. And every university can implement their own policies on who owns the data. For instance, either they can give access to everybody and make it as open as possible, or they can lock it down that the data office data stewards, they own the data and just delegate the sharing, and you have to proxy through the data stewards, for instance, to be able to really control access to your data. So it's really quite flexible, and many things that have been done within the science mesh, they work out of the box now in OwnCloud, Nextcloud, the OCM protocol. For instance, if you would procure through UDAT, the OCM API works out of the box with those Nextcloud instances as well. It only works because of those guys that they have defined the specifications, and it was upstreamed into the OwnCloud, Nextcloud code. Otherwise, it wouldn't be like that in the current state.
Yeah, there's one more idea. If your users or yourself as NRN do not run the EFSS systems, but run Microsoft's or Google's or whatever else, maybe you might persuade Microsoft to support OCM, and they will be very happy for them to join the federation. Why not? Okay, a bit forward-looking, maybe too far.
What?
You do it, I'll be right behind you.
Oh, okay. So, yeah, we have another question.
Yeah, I know there's a new ochre tender coming up for cloud, so would that be one of the requirements?
That would be a bit devil idea, but why shouldn't we try?
Well, I can try.
Now that you've mentioned tenders, there is right now a procurement ongoing from the EC where they've actually specified that they want to procure a central running sync and share system that links into the science mesh. Yeah. I am aware of some parties that have put in a bid for that, but it's underbidding, so I can't really say much more. But the fact that the EC have put that out there means that they too are militant enough to think that, first of all, this is an interesting approach. Second, that protocol and that modus operandi of linking things together, not just the approach, but the protocol itself is worth fighting for. And third, how about we own this for 3 years and see what the response from the constituency and perhaps even vendors is going to be. So it's an interesting space. So I was being a little facetious, telling Marci to try this, and I'll be right behind him. It may actually work to some degree. Right? Let's not get over enthusiastic, but it's definitely more interesting now than it was 4 years ago.
Yeah.
Go ahead.
Yeah, I'm the manager of research cloud at SURF, and we automatically link the own cloud instance at SURF into the cloud and the research cloud. So if a researcher deploys a VM, it's automatically mounted to this system, so they can directly start with working on it.
Yeah, we've had a lot of luck having Ron in this group.
Yeah,
so
yeah.
Thanks for lending him out.
Yeah, and I think this, even for a European setup, this would be really great. I can deploy compute somewhere else in Europe and then link it up to the system that's there.
Yeah, exactly. As a sane default. If a user if a user has no better tools, for those users that go, screw that, I know exactly how to operate grid FTP, whatever. By all means, let them do it. Yeah. But if a user goes, I need this data somewhere else, that degree of self-servicing where they don't have to go through the humiliation of filing a ticket and being rung in a day's time by a condescending IT person. This is for them to go tinker, and bloody hell it works. And then the word of mouth spreads, because that is how the humanities and the GLAM sector train each other.
Yeah, my
So
only,
we need to, it's tooling them for success. That's
Yeah.
the whole point.
the only thing that I'm missing at the moment, but maybe somebody is working on that, is the auditing part. So if I really work with really sensitive data, then I need to know exactly who accessed it. And yeah, if you keep it on the share and you only give access, you can do that. But if you move it around, say, okay, it's now from going from OwnCloud to Nextcloud, who will access my data on the Nextcloud part?
Okay, so there's,
So-
so there's two or
Yeah, but
three
it's-
answers to this.
it's
The
not-
first answer, this is working with the living. This is a target of opportunity. There are systems out there that explicitly don't deal with sensitive data. Node for node, you will see that the policy typically specifies, dear user, do realize that this is a Dropbox-like system, right? Again, node for node, we're noticing that some environments, some instances are trying to turn these sorts of systems into a bespoke secure data system. For instance, at Sunet. Have a talk to that guy in a minute. But there aren't enough of those out there yet that it makes sense to build a second mesh for secure data. It's hard enough to bring this thing up.
Yeah, well,
But it's definitely, we have to start with a case that if it breaks, it doesn't break in too sensitive a manner. But it's a very important feature. Yep.
I learned this week that seismological data can also be very highly sensitive. So,
Yep. The beauty, on the other hand, is, and that's a point Marci made earlier, is that the curation decision to share or not share lies with the user, not with the back-end administrators. We claim not to know shite about what the users are doing. We simply give them the tools and a few caveats. Do realize that if you share this with untrustworthy countries, you're sharing it with untrustworthy countries. But apart from that, it's up to them how they do it. And that's what's in the policy.
The only question I have there is the user would like to see what's going on. So if he shares it, it's okay, but you also want to have a dashboard saying, okay, these are the users that have accessed it.
Audit logs.
Yeah, audit logs.
Also GUI awareness, so that every once in a while you're reminded, did you realize that you've shared this file with the...
Files shared by you.
And then also for the newbies and the people that don't want to go into the log files themselves, but just have some alerting going on there.
Yeah. Concerning the safety of the data within the mesh, you can imagine, and it's technically doable, that based on the invitation workflow we could also transfer the cryptographic keys. And I can imagine that my data set could be encrypted with my local symmetric key. I could share some kind of my key enveloped by some public keys, which are my private keys, which I can share using PKI infrastructure. And we could, having the workflows we already have, we could add the key management stuff on top of this. But as it was already said, it was difficult enough to start with a simple use case, but the road is not closed. We could go towards the secure sharing. Of course, it would be easier and more sensible if at all the EFS systems would implement this as an existing feature. Then we could use the interface they have for this functionality and then only work on the, let's say, backend key management. The situation for now is that the most advanced support for encryption I have seen in the systems is this client-side encryption, so that actually server doesn't see the content. But based on that, maybe we could go farther. But it's the future perspective only for now.
We already have a pilot running for this.
Looking at the clock, it's break time. We have 30 minutes break somewhere out there, and I hope we can bring back the dynamic we had here.
Back at 11?
At 11, yes.
11, alrighty.
So maybe in the break we could put the demonstrations going, so that someone. No? Yeah, because I wouldn't stop the discussion. Yeah.
Tight for time.
Yeah.
Okay. Where's the beamer?
Well, I think before. You talk to the gamer?
I don't know. Shall we? Maybe you can talk. Maybe you can talk about this.
The invitation.
Yeah? I will talk about the applications. Okay. So I think it's time to restart our session. And in this part of the meeting, we would like to show you that the ideas, as it was said yesterday, that there was not only the idea and strategy, but also the implementation. So I will demonstrate three things for you. One is this basic invitation workflow, so-called invitation workflow, which is a set of activities which make up the trust relationship between the sites and also users sharing, enable sharing of the data between them.
It's off screen. Okay. So it is a bit of redundancy because I tried to explain it before, but this is actually the working mechanism of the invitation process. So we log here into the PSNC Nextcloud instance, and where your data lies, if you are the PSNC user who wants to share data. So yeah, apparently this user hasn't uploaded the data yet. But once this is done, PSNC, why is uploading taking so long at your network? They generate the mesh invite link that the PSNC user is then copying and sending to the colleagues he wants to share the data with. In this case, someone, well not someone, Milan actually, our colleague Milan from Chestnut.
This offline process on the site, I mean, it's out of the federation mechanics.
Yeah, this is just normal email. Yeah. He could actually WhatsApp the link or whatever. It doesn't matter how. Then Milan gets the link and clicks on it and ends up on this mesh website where he chooses his Chestnut instance of his enterprise file sync and share service. I think Chestnut is on cloud, right?
Yeah.
And PSNC was Nextcloud, so you see that it's working between different versions of EFSS systems. Then when he logged in, he can accept the invitation. And he can download the data, access and download the data, I guess. Well, he probably shouldn't download the data, but he has access to the data, so. Because, yeah, the purpose would be not to duplicate the data, but yeah.
Then we will be replacing the file sender.
Yeah. He could just have used file sender, right?
Or the other way around. Depends how hard you want to hurt me.
So I think this is it. Oh, what? Aha. Yeah.
They're visible in the client. That's
Yeah.
That's the thing.
You see the data in the client, and that's the basic sync invitation workflow.
So they can both create files in this place, or only that guy from PSNC can?
I think in that case they can
Yeah.
read-write access in that demonstrated case to the folder. So within the folder they can
Both sides can
Create files, yes. Yeah.
No.
No, you couldn't.
Oh, it's just a default, yeah?
Yeah,
The default is read write.
default is read write,
Depending
but
on what the individual sites choose to make their default. If a particular node decides that the admin
Now we
policy
can
is
stop,
that
right?
every share shall initially only be read, that's their right. hands of the individual nodes. All we're doing here is providing the interlinking glue. But precisely what, again, much like with Eduroam, if you decide that you want to be part of the mesh, but not allow users from or to particular countries to join, up to you. If everybody ends up doing no by default, then the whole thing crumbles, of course, but I'd be surprised if that happened. You'd be making your users unhappy. But I don't think we can tell nodes that you should be open by default or else. That's not gonna, that much stick. We need more carrot.
Okay, so the previous video demonstrated the, let's say, the simple, relatively simple use case where both sides are on the level of EFSS. So what they do is actually dealing with files. Yeah, they can open them in the editor, they can edit them, they can like change the content, they can move them, and so on. But we also wanted to show you that, as I said, we've got reached kind of very high level of integration with the Jupyter Labs, so that all this mechanics on sharing can happen somewhere beneath the Jupyter Hub interface. And this demonstration actually shows the case of people collaborating at the level of the application which is embedded into Federation. Yeah. Okay, so maybe you can read out this nice story, but what we want to notice is actually that because the Jupyter Lab extensions were worked out within the project, so we developed a Jupyter Lab plugin towards this common API layer, the CS3 APIs layer. The users, in order to, I mean, in this first step, it is shown that the user creates the notebook with the code and also the visualization components, and then shares them using, actually what you can see, he's not going to the FSS level, he shares them over using the Jupyter mechanics. So we extended Jupyter notebooks with the plugin, which speaks CS3 APIs, so it understands all the federation mechanics beneath. And thanks to that, this functionality, this complexity is kind of filtered from the user. So he can by only interfacing with the Jupyter itself, the user can share the data to the other user. And it's exactly shown here that after, of course, this kind of trust relationship has to be established between the sites and so on. This sites has to be in mesh, yes? So it's not that they can, again, you cannot just randomly choose the user with whom you share your data. And in that case, the other user opens the notebook. Now he can only view it because he has been assigned the viewer role on the Jupyter Notebooks level. So this role is kind of read-only access, which is mapped then on the Jupyter level. This is a reader role, which is then mapped to the read-only access to the notebooks at the other side. So what the Einstein user did, he could open the file, and in order to do some modifications, he had to save an extra copy of it. And now it is shown that you can manipulate the roles, and you can the source user, the owner of the file, the notebook actually assigned the editor role to Einstein, and then he can edit the notebook. And then we also will see that in order to help user to manage this access properly, we kind of enabled the locking mechanism, and we are kind of trying to expose within the Jupyter Notebooks context the mechanics which are typical for data sharing, such as I said, read-write access, and also locking, which avoids you, which you may use to avoid someone modifying the work you're on now. So it's kind of elevating the file system style mechanics to the application. In that case, it made sense, it was possible, because we also have relevant mechanics on the level of Jupyter, so we could map from one to the other.
So the web link is persistent? So, sorry, the web link is persistent? If I share this notebook, it's persistent? Or it can change?
In what sense persistent? I mean...
once generated, if I send it to someone, it will be forever a same link for this resource in the system.
But I'm not sure what kind of link you meant. You mean the one that you used to establish the trust relation?
You said you can export or you can share this notebook via a web link. So
No, I
you
said
can
you
send
could.
a link to other person.
No, the web link based share was before. I mean, here you.
Yeah, I understood this,
Mhm.
but you said also that you can Einstein can get grant access to Feynman, but also he can generate a link to share this notebook. Or not?
I didn't say so,
You
but
didn't?
maybe, yeah. Okay, I think the idea is that I mean, okay.
So Richard has shared his notebook with
Yeah.
Einstein.
Yeah,
Einstein only has read access.
yes. So he
And
opened this and then he saved another copy.
But you're telling me that Richard has access to Einstein's saved copy, are you?
If he shares this back, I guess.
If he's-
I mean, you can do the sharing on different levels. You can do kind of shares per folder or per, I mean, let's say on the basic level of the single share. Yeah, so I think in that case we're working in the shared folder where you can actually start sharing the notebooks which you create initially and then the other ones shared in the same space.
Okay,
I think that was the case in those.
in the example that was the case,
Yeah,
that
yeah,
it was saved so that Richard could see the modification. Okay, thank
Yeah.
you.
Behind you, back.
Thanks. So this only works with already existing users, right? Because you select a user from a drop-down list.
Yes. I mean, as we've seen in the previous demonstration, in order to be able to see the other users, you have to have established a trust relationship between the nodes, so that they can at least explore the other let's say the space, the other user space, yeah. This is actually this is what happens if you have the federation established. But in order to facilitate the common, let's say, the communication between the users, so that they don't have to. I mean, the other way is to use the links, because then the invitation link, which you get from the other user on the file system, on the EFS system level, this leads you to the screens which we have shown, where you can actually somehow, with this link, you can land on the federation and you can choose where you're from, and then you can choose the EFSS node which supports federation in general, and you can then say that you're from there, and then the whole mechanics will work because these nodes were previously included into federation. Of course, this will not work for the random user which is from somewhere else. Yeah.
No, I understand. I was just wondering if the user isn't in the plug down, but you do know his contact details. Would there be like an invite flow for this?
I mean, we're actually now working on some so-called address book for the users. It's not yet there, because as we said, this is a kind of gradual development what you're doing. So it's not yet in the interface level, but we are working. Actually, now there is the work item implemented by partners to enable so-called, we call it, this is temporary name, let's say project address book, where you can actually, there would be a step where you could go through the inventory of the users, and you can search, knowing your email or I don't know, something else. We could search the user with whom I would like to share, who is already recognized in a sense in the federation. For now, we don't have it. We're mostly based on this link exchange, because the reason for this is that we started with actual data share mechanics, and then this like user lookup feature is let's say not the future one, because we work on that, but it's coming.
Yeah, but basically what I was going for is indeed an invite flow where unknown users are invited to join, unknown but trusted users.
But then what does this actually mean?
Well, you know,
Trust.
your own cloud or your next cloud will only know users that have previously logged on. Not in Jupyter.
If the system is built that you can provision a user account, then you click on the share link, you go to your IDP, you provision the user account, and then you accept the link. So that can be part of
Okay,
the flow already
okay.
right now. If
So
you
there-
have permission to provision a user account.
Yeah, and what we're demonstrating there are actually the silent assumptions that we've got these users already. Yeah? There is a silent assumption which was not like elevated to the slides, but yeah.
So my use case would be that there would be some federated user identity management system that hooks into this. You mentioned federated identity in the beginning, but are you using any particular technology for federated identity? Or?
Node by node. Between the nodes, we're not,
Yeah.
not yet using.
So-
At the start of the project, we did look at both check-in as well as help me out here.
So-
Edge teams, of course.
Yeah, so you have edge teams.
At the time, didn't quite match the use case.
Yeah, but now it does, I think, because if you use edge teams or life sciences AI or some other systems that are out there, at SURF you have SURF Research Access Management, for instance. Then there you group the researchers into a group like co-manage does. And then you have researchers from different universities that are in the same group, and you want to use this to share the information between those people in the group, but are on different nodes from the own cloud.
Makes a ton of sense. We just had to make an architectural decision 3.5 years ago. Consider this the minimum viable product for.
Exactly.
But of course, if there are future rounds, future funding rounds, if we get traction, etc., then doing this in a more beautiful way obviously is a target.
Yeah.
You can even.
Fortunately, both check-in as well as edge teams have grown as well, so there are parallel developments. We're informing each other. We're aware of each other's existence. It's just you have to make a choice at one particular.
For the stranger user who is not yet in the federation, we could imagine even that we have some kind of catch-all instance of sync and share system like run somewhere, like in Poland or SURF or wherever. You could then create accounts in it so that the user has a landing place to be able to use the mechanics, but we are not yet there. I mean, this is far-going assumption that we would create these mechanics around the thing which we're doing. Now we're on a very basic, let's say, signaling level more than.
You can always misuse Sunak Drive, so we have this catch-all where you can.
Okay, yeah.
The EC have just begun a tender to get one. So
Yeah, exactly.
It's happening. It's all happening, but it's.
Okay, another question was, what do I need to install on the VM to make this happen in the Jupyter notebook? Is there some description somewhere?
I mean, if you want to run Jupyter notebooks with federations, of course, first you have to have sync and share speaking.
This whole recipe, right?
Yeah, this recipe, I can implement that easily, so everybody can just start it, basically. But
there's a manual and there's a repository with the images.
And technically, for Jupyter notebooks, you would need the Jupyter notebooks working with the plugin we developed, and then you could then speak to the federation, and you've got to have federation. So it's not like.
We'll take this offline.
Yeah.
Ron knows.
Yeah, you go to Ron. You go to Ron, basically.
The recipes are available, the containers are available, there's a manual, etc. I'd lie if of course you'll be one of the very first to install it. Right? Okay. We have the project participants, but they get a lot of hand-holding. But so there'll be bugs, but at the same time we're really interested to see people trialing this. So don't do this in splendid isolation. When you start doing this, give us a ping and go, look, I'm about to make a jump, help.
This is really powerful, I think.
I'm glad.
And this, maybe to summarize this part, in this particular case, we went quite far into investing time and effort into elevating these federation features into the application. In the other cases, maybe there's no sense to go too far, but because we had this kind of high level of interest into using this federated data science stuff, and one of the incentives was that Seren, as an important project participant, actually the coordinator, has this use case as a kind of daily business. So that's why we also went quite far into going into that application. We could consider integrating similar mechanics into other applications, but of course then your like say mass of the code you have to maintain grows. And we at this stage where we are, we mostly wanted to develop from one hand these important integrations which represent the typical science workflow, but also we didn't want to go too far, and these cases were mostly selected to examine different how we can integrate different aspects of the work, like data transfer, like publication, which we'll see in a while, and so on.
I think it's very powerful. I often have a discussion, or not often, sometimes have a discussion, why don't we put everything on SharePoint? And if you can present, if you present these use cases like this, then you can explain why you should not do that and use our own cloud.
Actually, even within the project for the data science case, we had an installation, if I'm not wrong, at JRC, which used the satellite data. And actually, these Jupyter notebooks were run versus these data sets, along with the visualization stuff based on Voila. And in the backend, they were using the compute cluster. So it was just a front end what we provided by running EFSS with the data interface and the Jupyter application embedded. But in fact, this was enabling this approach and this the whole solution which were given in the hands of the JRC users. It enabled accessing actually the compute resources through the nice data style of like Dropbox style of interface with some extras, and this is what we want to achieve also. As opposite to situation which we could have in public clouds where you mostly have these general purpose applications. It's hard to compete with our integration of only Office. It's hard to compete in a sense with the super nice integration of Office 365 into public cloud stuff, because functionality wise it's much better, but we can hardly imagine that the big players would be incentivized to embed Jupyter notebook stuff with, let's say, access to GPU-based cluster for your visualization or for your analysis work. And we think we are in position to make it. And there is a need for it, and we try to kind of address it. Yeah,
also in the AI application space, I think this would be really powerful. And indeed, if you want to compete with Office, then it's another playground, basically.
And we also see that Jupyters are appearing in many, many places which we wouldn't even expect them to appear. And let's say, usage of Jupyter notebooks is included in many curricula of universities, of business schools, and so on. So it's also becoming some kind of de facto standard for data analysis. And if we have this application, that's why also we invested into it quite a lot of time. We could really catch many users, and we attract many use cases with this software stack, and services stack.
Our studio would be number 2.
But of course we were aware that this was actually kind of the choice where we go, and we are aware that R is important for perhaps other type of users. But again, this is a future perspective. We wanted to start with kind of a proof of concept, useful proof of concept based on the key users we talk to now. But as you say, this is a possible future extension.
So the point isn't to compete with Office. The point is to have one interface to the outside world that third-party cloud providers could link a service into. If you decide that you want to locally run an Office clone, sure, by all means, they are available as packages. Collabora, only Office. But if every site that we have in this mesh presents a WAPI interface to the outside world, then outside third-party providers, even Microsoft themselves, could provide a service into this mesh through a single, I know it's hip and trendy to say marketplace, that's not what I necessarily want the whole thing to look like, but if we present a common interface to the outside world, small and niche operators will find it less onerous to provide a single service rather than to have to tweak and tune it to 15 APIs out there. So we're hoping that that will invigorate and remove the need for particularly smaller sites. CERN will probably always continue to run their own local version for all kinds of proprietary reasons. But a smaller site that wants to augment their own user-facing service and not be battered by users going, I can't edit my documents. So you might want to, it enables these sorts of things. There might even be, we may have a slide about this, there's ways of getting a third-party Jupyter service in as well. EGI happens to run one. It's pretty easy to tweak the interfaces so that both services talk to each other. Voila, again a pun. There's your Jupyter service running on, so it's basically the whole notion is to make this look like a cloudy system rather than an enormous amalgamation of individual nodes and then manage those interfaces.
That's the idea. So not so much competition. I understand.
Yeah, maybe that's what's like.
Yeah.
Okay.
All right. Good.
Okay, so I think we can stop with that use case, and we could switch to the other thing we want to demonstrate to you. It's actually based on the work of Münster University and also SUNET, who joined the mesh, and also the project work. Let me just scroll back, sorry. So we'll now present you the case where people actually, while they, based on the work, based on curation and preparation of the data which they do within EFSS or outside, they have their data in EFSS and then they deposit this data to the repository. So we will see how this looks like and how this works at the moment. So, I mean, this work is based on the integration of the sync and share service with research data management application, which is called SkibarDS. This application, this extension enables sharing, I mean, depositing the data to the repository from within the EFSS interface. Again, we could do it separate. This could be a separate workflow, same as for Jupyter notebooks. But we assume that the more interfaces and the more workflows we can support from within the institution mother institution data interface, data storage system interface, the better it is for the end users, and it enables avoiding duplication of data, this cumbersome manual process, and there are two aspects in which we support users, at least two aspects, the two important ones. One is that by default we require users to enrich their data before the deposit with the proper metadata set, and for that reason we adopted a kind of let's say also popular in the de facto standard for metadata for descriptions, which is RO-Crate. And this tool actually integrates this RO-Crate standard as a way to describe the data. And so the deposition process includes, of course, selecting the data sets to be deposited, also adding the enriching metadata to the data set if they were not added earlier, and then depositing this to the repository. And as you can see, and you will be able to see this data are transferred to the repository by the means of the EFSS system extensions, and through the tool they get they land in the repository and they are searchable in the repository. And this is again now done for some selected repositories. I think the demonstration was about the OSF. There is integration for Zenodo, and there are plans also to enable deposit to Dataverse repository, Dataverse-based repository, which is also getting popular now for many reasons. So it's on the roadmap, and again we had to make a kind of conscious decision that we limit ourselves for the time of the project implementation to enable one or two of these repositories. But it's the good thing is also that the whole tooling attracted new users, and SUNET joined, for instance, SUNET joined CS3 Mesh project, and then actually the whole solution is already running in SUNET and it's tested in SUNET. I mean, maybe not running in production, but it's tested, yeah? Okay, next, yeah. We also know that there is an interest from SERV to enable this. Also, there were discussions on working together with Dataverse plugin. So again, it's kind of we started with some selected technologies based on their popularity or matching the users, the interest of the users we had on board during the project, but we're quite open to go further with this. Okay, so that would be it for the demonstrations, and we can now come back to the. Unless you have some questions now. F5, yeah? you can see maybe we can come back to that place, because we started to speak about the adoption beyond the original consortium. So on the left part of slide, we have the project partners. And as we said, some of the institutions mentioned here are already testing or porting the solution to their reality. For instance, in case of SUNET, this porting effort not only includes joining the mesh and also porting, let's say, moving from solutions from one place to the other, but the original solution based on Skibo system, which is on-cloud based, and Skibo RDS tool, it has been ported to the Nextcloud as a basic EFSS system. And it's actually already happened, so it also shows that we can not only replicate the mechanics, but also put them on top of the other system as long as it complies to these basic architectural assumptions. Yeah. And there is more discussions and also ongoing work on adopting the results from the project and these institutions mentioned here. Okay, so we should then go to the third aspect of the project, yeah, because we covered two.
My turn?
Yeah?
Yeah, all right. This is the mercy shot if you're all struggling after 6 days of conferencing and it's late and you're tired. I'm about to talk about policy. Mwahahaha. What? You don't like that? But much like with Eduroam and Edugain, it's technologically relatively easy to describe. It just needs to happen. And for things to happen, for people to come together in a sustainable long-term manner, you need something in place. So that's something that we've been working on as well, which is, given that we're a group of engineers, might not be our sort of first-line hobby and or nighttime reading material, but we did anyway, and I think we did rather well. When did you move that slide in? You get the... These are not my slides. I don't know what to say. See, I'm struggling to... It's the other set. Oh, it's in Italian. Presentazione standardi.
I have no clue how you bring this to the other screen, actually, because this is PDF. No, it's PDF.
Get a competent person in.
Which one? PDF?
Yeah, it's a PDF.
So this is a kind of standard, yeah, at the end.
Policy needs to be printed in PDF.
Yeah, exactly. And signed.
Electronically signed and then...
This like that? Oh, so mad. Oh, now it disappeared.
I have to stop PowerPoint.
Yeah. Okay.
Well, make it full screen, that thing.
Full screen is Command L on Mac.
You think it's a
Mac?
Mac?
But it's not Mac. It's not Mac. If this would be Mac. Yeah. I think F11? No. How do you do full screen in Windows?
Maybe it's Control L.
Here comes a competent person.
No.
Yes.
Yeah, okay.
Don't say that yet until I've actually done it.
You've done it before.
All right.
That makes him competent. I've screwed it up.
You've got the
Yes.
Let's see.
Enter.
Oh, it's so.
Control L.
I can scroll through this too. I mean, it's big enough.
It's fine. Okay.
Can you do the presentation as well? But now I don't. So can I? So I see the other prezzo now. I can. This is amazeballs. I just have to look here. All right. So this is about setting up a thing, putting a thing in place that will eventually grow with the administration of the mesh. The first iteration doesn't have to be perfect, right? We're just putting something in place, and we're relying on the initial group of early adopters, collaborators, the willing, etc., to shape it into something, the shape that it needs to have. So what you're about to see is all line items. Don't be excited, but it's a proposal. It's what we have in place right now. It's based on Edugain, so it shouldn't be surprising. So we've adopted the structure and most of the bylines from Edugain, so it shouldn't surprise you, and we know that works. The principle is the minimal requirement and sufficient requirement to begin with is that you comply with the technology, the APIs, the type of system, the architecture. But, as I pointed out
during an earlier discussion, you become a member of the governance of the mesh. It doesn't mean that you can necessarily communicate with other nodes. There are no guarantees. You will have to earn your trust. We assume that every node will simply be open by default, much like in the end we ended up running Eduroam. But initially, the first years of Eduroam, if you're as old as I am, some nodes decided to be closed by default and only open for people or entities that they trusted. It'll grow. So we don't start with an onus on the existing nodes to trust new entrants. We've got these documents ready already. We have a declaration, which is a 1A4 piece of paper with some home truths. We understand, you as an individual node sign it unilaterally, and you basically send it in to the operators of the mesh as your application form. And it basically says very, very simple home truths. I understand that this is a mesh. I understand that this is about this particular technology. I understand that I need to play by the rules. I acknowledge that the next document to be signed is the Constitution, etc. It's a simple A4 piece of paper, and it acts as the immutable basic principles and the application form, essentially. Then there's a Constitution, again, borrowed from Edugain, that has, yeah, exactly. It describes the basic structure, the governance body, the entrance procedure, the exit procedure, home truths. It can be changed, but by a constitutional majority. So we don't want that thing to be we don't want that thing to shapeshift too often. It shouldn't, ideally it shouldn't change, but if it needs to change, it can, but not too often, preferably. It shouldn't be thrown around. But that thing in turn refers to a next set of documents. And these are the documents that should be living documents. We have a first version of them in place. The DOIs are all over there, but if they don't change, then apparently the architecture hasn't changed, and that is not healthy. Right? So this is where we expect the fine-tuning to happen. Yeah, easily adaptable. That's what it says. We'll give you these slides after the meeting, etc. They're also obviously on the project page, etc. So they're findable. We want you to be aware of these when you send in the declaration, because they are part and parcel of the first iteration. And then we have already put in place a sort of a slapdash version of these based on the structure that we have right now in the project, on the project funding that we have. It's about to, the project funding is about to expire in 4 weeks' time. So from that point on, it's all voluntary, but then so is Edugain and so is Eduroam. So this is the structure right now. We have an executive board, a steering group, and an operations team. Yeah, the point here is you can already start this. If you send us one of these declarations, as Sunet, for instance, have done, who are not a partner but are now an onboarding member of this mesh, you can start this process right now. You don't have to wait for anything. In fact, we'd be glad if you did. We've also set up a help desk, which in 4 weeks' time will actually be running on volunteer labor, but again, there is not too much to be done right now, but it needs to remain in place to tide this thing over until it actually becomes a living thing. But it's in place, and that's the thing you'll be communicating to when you actually do the technical parts of setting up your links to this mesh. So here's a question. The structure will be the day-to-day operations will be in the operations team. The sort of quarter-by-quarter or yearly tweaking of the documents will be in the steering group, which every member of the mesh is entitled to send a representative to. You don't have to, but that's where the voting happens. But a kernel of immutable oversight will sit with the executive board, and that's only staffed by people who actually contribute person power to the help desk, monetary contributions to the operations of this thing. We're shaping this as we go. It doesn't mean that there are tiers and there are privileges. Does that work? You're a member of the core group, so which is not an answer. Damn, he called me on it. I hope so. It's worse than that. Guess who drafted these documents? Ron drafted it. Still no answer, but I think they did.
Yeah, I saw in the presentation that said Surf Sara, but that's
Yep, that's how long. Oh, this is how you're trying to wash your hands. I have no idea who those people are. Yeah, exactly. Anybody who's represented with the wrong logo, you're scot-free. Yeah, I think you've signed. Yeah, yeah. But if you haven't signed, then that's because you don't agree with the structure of the documents, and which was written by. I'd be massively disappointed. Most of the work was Ron and Milan Danacek at CESNET. And David as well? Antoš did, well, I think he oversaw and Milan did most of the writing. Anyway, CESNET did a whole lot, and you were involved in the security declarations, right? Yeah, okay, so they're definitely bona fide. And I was not involved, so that's a vote of confidence. So, if there is discomfort, now is a good time, but also as you onboard, just explain how you think. But we've basically gone with what we think are sane defaults. We haven't put this in place because we absolutely want to, it's not clutching power. It's just that I think people who are most invested into a particular structure, if you let them run that sort of operation, it just is the way, that's the consensus democracy around most open sourcey things. So, all right, anyway, I'm sensing not too much dissent. All right. Then there's the third thing where, which hinges on what I was explaining around how we want this thing to smell like a cloud on the outside. And therefore, we think we can also insert it into the structure of EOSC right now because it can be a horizontal capability underpinning all of science. So instead of providing country-by-country capabilities to country-by-country verticals, which will not be the structure of future EOSC, we think that if we insert this as a horizontal layer, we stand a better chance of being useful and fundable, of course, to future generations of EOSC. But that comes with an extra onus, in that if you want to insert yourself into EOSC, you don't just need a privacy policy in terms of use, which we have, that was in the previous documents, but also an SLA. We think we can get away by presenting like a minimal SLA towards EOSC and then onwards referring to the individual SLAs at the nodes and then simply in policy saying we will let the policy at the individual nodes prevail over the overall policy. We think that's enough. EOSC itself is a work in progress, so I'd be surprised if they were so stubborn that they would exclude this entity, this cloudish capacity that we're hoping to vend in on the basis of the absence of a central SLA, but it's a work in progress. So this is what we propose to propose. But again, it's up to the crowd. If you think that that's either too weak or can be done in a different manner, speak now or be silent forever. There's a question. Fantastic, thank you.
This is better. So I just skimmed the documents. Doesn't actually seem to say that you have to be in science or education or not non-profit. Is that a conscious choice?
Which document?
The declaration.
Yeah.
Yeah.
No, the declaration wouldn't. No,
Okay.
no, that's because it basically says so on the declaration. If you sign it, we know who you are. It might say so in the Constitution. That's a more logical place, but it doesn't.
I'll get back to you in 15 minutes.
I'll be in a taxi by that time. I hope, fingers crossed. No, but again, first of all, work in progress. It may simply have been an oversight. I don't think so, but it's a question to go back to but it's a good one. I'd say that it would make sense, much like how we did this for Educate and Eduroam. It has the Edu, maybe we should call this thing Edu Science Mesh. My gut feeling would be that we need to stay close to that concept and maybe spin off something else otherwise, but the declaration wouldn't be the place to do this, I don't think. But it's a good question. Noted. Another one.
Yeah, I think this is the same policy that we have also with a public cloud or commercial cloud vendor. You can only provide as an NVEN what they provide to Zeon, and that Zeon has bought them and
Yeah.
provides to Rackspace, for instance, and that Rackspace provides to our NVEN, and then we provide it to the university. So there
Yeah.
are multiple steps in between there as well. So
Yeah.
that would be the same logic as we have.
This is exactly, yeah, that's the logic, and so you get it. You get the fact that we are more of a broker than an actual facility. Whether EOSC gets this and wants to get it is the second question, but I think that through robust dialogue, and particularly if we can say that all potential participants of this thing have sat in the room and nodded, that's enough of a, can we?
There is such a thing as EOS Marketplace, and is it working or not?
I have no idea.
There is EOS Marketplace. Are you planning or have you onboarded any applications of this system or subsystems as separate applications to the EOS Marketplace?
No, not yet. We're in the process, and these sorts of things need to be settled first. Okay. Yeah. So it needs to happen, but it's everything is a moving target at the moment. We definitely don't not want to.
Or a couple?
Good question. I think it would make most sense to do this as a single application, but that makes it harder, conceptually harder. The individual nodes, of course, have full freedom to also rock up to EOSC and say, hey, we want to be onboarded as individual nodes. We have no say or sway over that. The strength that we're offering, or that we think we're offering here, is amalgamation and joint representation and greater simplicity for end users. But it makes it more complex. And because EOSC itself is also a moving target, it's just we're working on it, but it's...
Maybe EOSC is too complex.
It's complex. It certainly is complex. It's a lot of things to a lot of people. And this is not an uncomplex project either. So you're trying to mesh two complex things together. I have full faith that on both sides of the deal, people want this to happen. But everybody's quite busy. That's not an answer, is it? But it's the truth. So, all right, I think that's it. So the main takeaway message is policy is being done as well. Don't think that we've just done the technology. We're also ready, if you as an engineer want to start the onboarding process, don't feel that you will be caught with your pants down when you start talking to the legal and procedural people inside of your organization. We have stuff that they can look at, and it works because we've already onboarded non-member sites. All right, that's it for me. Questions? Questions? Two questions. What have I done?
Just a comment that WLCG have got a similar federated thing with policy, so if you haven't looked at their policies, it might well be worth looking at them. If you have, great.
That's a funny one, given that this project is led by CERN.
I'm sure they've looked at the policies then, so they should be fine.
I'm not sure. I think WLCG, the Worldwide LHC computing grid.
For the security, we looked at the ARC framework.
Yep.
And I think Ron looked at the EGI stuff.
As well.
EGI is very closely related. So if you've looked at the policies, that's fine. I just thought
that's a good comment. Yep.
Yeah, we had some discussion that we produce rather good software while not being paid, and that proprietary software makers are really bad and suck at producing software when we don't pay them. Is there any payment model involved here in this part?
So that's the bit where... Am I going back? I'm going back, right? That's this bit, right? So we have this structure, where we know that we'll have to have an operations team and an executive board. The steering group is basically voluntary. You rock up or you don't. But we do need to have some people volunteering something. And that it hinges on a central group of people being willing to put forward resources. But there is no paid membership model. No. Again, much like Eduroam and Edugain. No. Although in the end, they ended getting funded over the top as well, which... that would come in handy, it sure would. But I think for the moment, the most important thing for us to do is get critical mass, which you will slow down by asking for a membership fee. So by the time it is big enough and useful enough, levying some sort of tithe might be, but it's, what was that?
Now you need to pay.
Nobody expects the Spanish. No, it's hard. It's a hard game. It's, as I think we concluded during that session, it's a hard game. It eventually needs to, we are, for that exact same reason, we are making sure that the central coordination is as lightweight as possible. So the only stuff that needs to run centrally is some monitoring stuff, some brokerage stuff, but the actual meshing of sites is completely end-to-end. So the logic runs at the sites.
For Research Cloud, I had a little bit different approach, saying as long as I can get it funded, it will be for free. But if I don't get it funded anymore, your data will be in it, or it's part of your infrastructure. You are using it. So if I don't get the funds eventually, it's up to you if you decide to spend money on it, to keep it alive. Basically, because it's in your advantage to keep it alive because you've invested in it. So it's free if we can fund it. But for continuity's sake, we implemented something that eventually you can pay for it.
Yeah, which is also the reason why we decided to build this as a mesh of sites that themselves are funded and sustainable through national means, typically.
And technically, we didn't want to intervene with the standard protocol that much, so that you can still run and operate your service, even if the mesh, in a sense, goes down. Because your users mostly interact with your own EFSS. You drive, and then these sharing features come on top of this.
All right, that gives us 3 more minutes. Such timing.
So at the moment, GIST seems to buy, not build. So if one were able to buy this sort of service from somebody, that might be interesting to GIST.
Where did you hide the closing slides?
Well, it's probably
the EGI slide.
Oh, the EGI slides.
It's on your EFSS.
Yeah, we're doing this.
It literally is. This literally is all on his.
It's just the HTTP redirect between us.
Absolutely. 404.
That's how federation works.
So, it's just one slide. That's okay.
But still, F5.
F5.
Yeah.
Yay.
So maybe as a hosting institution representative, I would like to invite you to join the Science Mesh related activities during the EGI conference in Poznan, which will be held in the third week of June, so actually in 2 weeks. So perhaps it's a bit late to now plan the trip there, but you still can go online, and I think many of you will be in this meeting anyway, so you're very welcome to join the Science Mesh activities there, and we'll be also discussing there. I think we hope for similar type of interaction discussion with people involved in GI-related activities on how we can actually make this Science Mesh fly in future. So come to Poznan. It's a nice place. We will make you feel comfortable.
There'll be streaming links as well, right?
Yes.
So
yeah.
You don't have to physically travel, although recommended.
Yeah.
But
you have to register for the online version.
Yeah, the registration for the online meeting is free, but we just want to know the list of participants. There will be also discussion panels, so that's why we ask for registration, so that we also can adapt the panel agenda for this. So, okay.
Okay.
Will the streams be available later?
Pardon?
Will the streaming be available later?
I'm not sure. We can check.
This streaming not.
But those.
EGI.
Oh, from EGI, yeah.
Oh.
They'll be,
I have no
you guys are
idea.
streaming that, aren't you?
Yeah.
Yeah, will it be recorded? Will it be recorded?
We can figure this out, I guess.
Figure
Yeah.
this out.
Okay.
Thank you very much for.
So thank you.
I think. Food might be at 12:30 because we're a bit out of schedule for everybody else, but yeah, we'll see. And it's in the room over there, I guess. Actually, I don't know. We have to figure out
That's
food.
very honest of
Yeah,
us. Probably is.
but we have half an hour to figure out. Thank you.
Food is already there.
Who knows?
Who
Yeah,
knows?
and
No
there's
queues.
line.
find out. Let's go.